Let's say question 10. It's not totally about it's not really about the equilibrium, but so the box is set into acceleration to the left. So what happens to the box? And then if you remember, we have talked about one skill. So that is the equivalent gravitational acceleration. The equivalent gravitational acceleration will be the g minus a minus the acceleration. So it should point somewhere to the right bottom corner, okay, in this direction. So that means you consider the Earth is tilted by some angle, such that the gravity acting on all the objects are in this direction. So therefore, this ball will be inclined like this, and this ball will be inclined like this. Okay. So this is the wooden ball, is it? Which one is this? Is iron ball. So this is a wooden ball. And then if you want to find the angle, and then you can, of course, you can find the angle easily. Okay, so only the iron ball is inclined to the right. So the answer is B for ball. Any question? Just make use of this skill, and then you can do the question very easily. Okay. Oh, then let's move on. Then let's have a look at similar to question 7 嘅. You have a look at the question first. You make use of the same skill, and then you find the answer and send it to me. Yeah, you find the answer and send it to me. Just you make use of the same skill. So may you give me your answer? I think it's not really difficult to do it. Have anyone finished it? No? So have you finished it? If you have finished it, you vote for the answer. How about the other two? So one of you have answered the question. So how about the other two? The oscillation move horizontally with some oscillation is like but I think you need to understand or you need to determine whether the oscillation is to the left or to the right by yourself. And you can do it, most likely. Okay, three of you all choose different answers. Three of you all chooses different answers. Send it to me. You may need to do some revision on the topic of force. You look at the notes by yourself. So you talk about one very important point. One very important thing is the point of application, the point where the force act at. So the weight at the center of the rod, yeah. So maybe somewhere here, and then the buoyancy is at the center. We call it the center of buoyancy, or just say the geometric center of the part under the water surface. So that is the center of this part. This is the force of buoyancy. And then this hinge, I told you that whenever there's a hinge, you need to consider forces are in two directions. But for this case, you just need to consider one direction is enough because all other forces are vertical. So then you consider this force is upwards vertical. That's it. And then you want to find, you have the magnitude of the weight. So that's a density. You know density times the volume is the weight, but the cross-section area is not given. You may consider it to be A times G. So this is the mass of the rod. And then the volume of the magnitude of the buoyancy will be the density of water times the volume. Volume displaced, so that is the volume under the water times G. The hinge always gives the force on the rod. But why you doubt whether it is upwards or downwards or if you want to understand why it's upwards, okay, first of all, I've told you that it can't have a horizontal component because the rod is in equilibrium. There's no other horizontal force. So the force acting at the hinge should be vertical. And then if you take the moment at this point, so this provides you a anti-clockwise moment. So the force acting at the hinge should be upward, such that it can provide a clockwise moment to compensate the anti-clockwise moment. And then if you take the moment at this point, then okay, so you don't have the length, but let's say if you let this angle to be theta, then the moment of the weight times the perpendicular distance, so that is alpha 2 cosine theta, should equal to the moment of the buoyancy. The length will be x plus L minus x over 2 times cosine theta. Then after you simplify after you simplify it, and then I think you are able to find the answer. So I'm not sure which one is the answer. But at least I can sort out some of the choices, I think. So let's say if the density of the liquid is larger. Okay. So that means it's no longer water. So that you may consider, let's say, mercury, and then the density is much larger, and then the buoyancy will be much larger. I think probably you can see that the X over L will be larger, the ratio. That means more parts of the rod will be above water. Then you just have a look at the choice, which if this one is larger, it will give you a smaller X over L. So this should not be the answer. And then this one should not be the answer also. So therefore the answer is either B or C using this analysis. Okay. But of course, most likely you need to solve it and then to know the answer. But at least we can shout out two choices, even though even if I don't uh, uh, take the moment, okay, I can still get 50% to get it correct. Okay, you capture a screen or you drop it down, and then let's move it. Dang. The photo I suppose it is sent to you. Where is our group? I can't see it. Okay. Okay, done. So let's have a look at one more year's question. The questions are really tough. uh, yeah, we are not aiming to get full mark. We're just aiming to get 50%. So let's have a look at question. No, then I think there's no question about the moment in this one. Okay, let's have a look at question 4. So this question asks you to find the center of mass. Center of mass. Yeah, it's really tough. This one is a bit really tough. Question 4. So you have a look at this question first. So it asks you to find the position of the center of mass of this system relative to the origin. There's no way for you, is it? First of all, can you find the total mass of the object? Total mass. So the total mass will be m 1/2 plus 1/4 plus 1/8 and so on. We have talked about this kind of infinite geometric series. And then I have told you how to do it. Is it? You need to know how to you need to memorize the formula by yourself. So that is A plus AR plus AR squared and so on. That equal A over 1 minus R. So then that will be 1 half divided by 1 minus 1 half, give you M. So the total mass will be M. The total mass will be M. If you want to find the center mass of the system, so you can do it like this. The total mass is M. Do you still remember what is in the numerator? So it's the mass of each individual object times the distance to there, M over 4 and then 2K, is it? And then plus M over 8 times 3K, and plus and so on and so on. So if you simplify it, and okay, of course the M can be cancelled out. I just take out the K. Okay, I just take out the K. So it become 1 half plus 1 half plus 3 over 8 plus 4 over 16. Or I'll write it like this, okay? Maybe I write it like this. So 1 over 2 plus 2 over 4 plus 3 over 8 plus 4 over 16 plus 5 over 32 and so on. This is neither arithmetic series nor geometric series. So let me ask ask you this question. Do you think that you are able to find this series? Then what you should do in the exam if the question is like this? But first of all, there's another trick to do this question. But at least I hope you understand this is the definition of the center of mass, how you find the center of mass. So at least I hope you know how to write down the formula like this. So even if you don't know how to solve this series, what you can do, you know the later term will be smaller, smaller, and smaller. So what you can do is just to use your calculator, is it? So you just press 1 divided by 2 plus 2 divided by 4 plus 3 divided by 8 plus 4 divided by 16 plus 5 divided by 32 and try to get as much as you can. So I just add up to 7 divided by 128 and I get around 2, 1.9 something. Then I will think that you choose the answer C. Okay. At least I hope you can just make use of your calculator to get the answer. But to solve this series, okay, there's one trick you can do it. So you multiply by 2 in this series. So you get 1 divide 1 plus 1 just write it as 4 over 4 plus no. So I just rewrite the series like this. So 1 of 2 I rewrite it as 2 over 4. 2 over 4 I rewrite it as 4 over 8. Oh no, I can't. So let me see what I can do. So I multiply by 2 first, okay? Multiply by 2 first. Do you see the trick? If you do the 2s minus s, okay, you do this term minus this term, this term minus this term, this term minus this term. So what you get is so 2 minus 1 half, and then this one is 1 over 4, is it? Plus 1 over 8, plus 1 over 16, and so on. So this gives you here, this gives you a geometric series. Then you can solve this sum. This is 1 half. So therefore you get 2. So that's why you S equal 2. But this is not a physics method to do this question. Okay. So you capture a screen. The physics method to do it is like making use of one symbol, one I call it the trick. One of the trick. The trick is like this, okay? I call it the infinite equal to infinite plus 1. So there are two systems that I consider. So the one is the red one, okay, the red one. The one is the blue one. So can you see what is the difference between the red one and the blue one? The red one, the first term is starting from m over 2, m over 4, m over 8. The blue one, the first term starting from m over 4, m over 8, m over 16, and m over 32. So they just differ by the factor of 2. Okay, the first term in the red one is double of the first term of the second one. Or you just say the mth term of the the m term of the red equal to double times m term of the blue one. And then we can so first of all find the total mass of the red one. We have found it, is it? So the red one, the total mass is m. The blue one, the total mass, you know every term is just half of the red one, so the total mass should be m over 2. Just that simple, is it? And then if you consider the center of mass of the red one, so let's say the center of mass of the red one is somewhere like in this position, just for example. So let's say this, let it to be x. If you consider the center of mass of the blue system, it should give you the same value, because every mass is just halved. Okay, sorry. The arrow should measure from the starting point, so this should be also x. And then we can just, and then we make use of this skill. So what I call is infinite equal to infinite plus 1. And then I just make use of this skill. Sorry, I may need to move the blue system a bit right here. And then, okay, so, and then right now I consider just m over 2, the system of m over 2, and the system, m over 2 and the blue box, or the blue system. So the blue system, the center of mass of the blue system is x, distant x from the point of m over 2. And then the total mass is m over 2. So this is k. And then I'm going to find the center of mass of the red system. The red system is just m over 2 with the blue system. And then the center of mass of the red system should be x, is it? So x should be m over 2 times k plus m over 2 times x plus k divided by total mass. Then you get x to be, just simplify and see what you get. X you get equal to k plus x over 2. Then you solve it and then you get x equal to 2k. There's one question in HKPhO. You can make use of the same trick to do it. So whenever you see a system involve infinite objects, then you just make use of the same trick. Okay, so for the part of center mass, that's it. Nothing else you need to know. You save it or capture your screen. So maybe let's have a look at the question 7. Maybe let's have a look at the question 7 here. You take a look first. Maybe I'll give you some hints to do it. Now, it's better for you to consider the reference frame of the car. So the car is a non-inertial frame. So you need to add the inertial force on the object. So there's a inertial force, there's a weight, there is a normal motion. I don't know whether the friction is to the upwards or downwards. So it doesn't matter. So let it to be upward first. Now then you solve the forces. Now, if you consider frame of the car, then the object is at rest relative to the car. So the object is at rest right now. Then may you find the value of the friction. So I'll just give you 2 minutes. I think that should be enough. What I get is C. So you know this is 30 degree, so this is 60 degree, or just say, and then you take all the forces along this direction and along this direction. Why I take it like this? Because I don't know the magnitude of n, so I don't want to decompose the force n to two components. Otherwise, for those two equations, you have the unknown n, and then you need to solve it more complicated. So I solve it like along this direction. So this mg cosine 60 degree should equal to ma cosine 30 degree plus a friction. And then after you solve it, and then can get the answer C. Okay. So you see that these few questions we have done have used the skill I've taught you. So yeah, then question 8, I think if you still remember, I have told you about it. The minimum value of U. So this is about a projectile motion. We have a formula for it. Question 6, we have done it before. A similar question, we have done it before. So question 2, I've done similar question in the first few lessons. Question 1 is a simple question. So for this year, I think the question is much more easier, much easier. So then I have a meeting soon with a parent. So sorry, we need to stop here. And then so let's meet on Wednesday. Let's meet on Wednesday. And then on Wednesday, then we'll go to have a look at the energy.